Hi crew, this is Parfait here. I'm going to make a short tutorial video here where I'm going to quickly show you how to model a bearing plate and tie it with a flange shell element. And so it's going to be a quick short video. And so how do we model a bearing plate? Because of the thickness of bearing plates, we have to model bearing plates usually as solid elements. In the previous tutorial modeling videos, all of our modeling have been done as shell elements. When we do bearing plates, we're going to model them as solid elements because they are very bigger plates in terms of their thicknesses ratio. So we are required to kind of model them as solid element to get the proper behavior in the analysis when we're doing finite element numerical methods. So how do we model? So this is a bearing plate that I'm going to quickly show you here. This is a loading bearing plate. So what do I mean by loading bearing plate? It's the plate that is placed right under where the load is applied. We also have support bearing plates, and those are placed where we have the supports on your structure. But we're going to learn how to do a loading bearing plates, and it's the same concept and process when you're doing support bearing plates as well. So how do we model a solid element? So we're going to do a new element on your ABAQUS module here. You're going to click on the part icon. We're going to create a new part. We're going to call this bearing plate. I'm gonna call it bearing plate 33 because that's the width of our bearing plate. And so, right, we're gonna keep the type as deformable. The modeling space is always 3D space. And then the shape of itself, this is where we choose it as a solid element. And our extrusion, we're gonna keep it as our type, we're gonna keep it as extrusion. And we just click continue. And then it's going to load a new window for us where we can start modeling the solid elements. So now the bearing plate that we were modeling has a width of 33 inches and a length of 22 inches, but the thickness of our bearing plate is 3 inches. So that's what we're going to do here. I'm going to just draw a rectangle, a typical rectangle, and I'm going to change the dimensions. So click on the dimension. I know that my width is going to be 22, and then the thickness, which is this height here, is going to be 3 inches. And we click enter. And then we're going to X out of this to extrude our material. And then now the depth of my bearing plate is going to be 33 inches. Right in this box, we put 33, click OK. Now I have a bearing plate that has a width in this direction of 22 inches and a width of a length over here, width of 22 and then a length of 33. And the thickness is 3 inches. So now, since this is a loading bearing plate, I want to partition this bearing plate exactly in the small area where I'm going to apply my pressure load. So what we can do is partition the bearing plate as well, and you can go back to previous video to see how you partition shell elements, and it's the same concept when you're partitioning solid elements. So we're going to select our partition icon, and then we're going to click on the face, and we're going to do the shortest path between 2 points, and we're going to select the face of this partition, and I'm going to select this face as well, and I'm going to rotate it, and I'm also going to select the other face as well. And so let me see, one moment. So now I've selected this face, the top face, and the other side face. I can click done. I get an error message, so it's asking me to do one by one. So that's what I'm going to do. I'm just going to select one face and click done. And I'm going to select the point is going to be this starting point, and the end point is going to be that endpoint. And I'm going to click create partition. So now I've created a partition here. And now we can also create more partition. I'm going to do it again. I'm going to select this face, click done, and I'm going to select the bottom point and the top point, create the partition, and I'm going to rotate it on this side, do the same thing, select the face, top point, bottom point, create the partition. So now I've created my partition in here, but I want to create an area of an inch on my bearing plates because that's exactly where I'm going to apply my pressure load. So how do I do that? I'm going to also go back to the same, create the partition, same face. Now I'm going to select the sketch. And I'm going to select the face in which I want to sketch. So it's just going to be at the top here because that's where I'm going to apply my pressure load. Click done and select an edge, select our edge. And so now I'm going to just offset this center line ½ inch above and ½ inch below to create a width of 1 inch. And so we can use the offset option, and I'm going to select the offset option, select the center line, click done, and then I'm going to put 0.5, enter, click OK, and then you see we have created 0.5 below, and select the center again, click done, 0.5 again, but this time I'm going to flip it to do it above and click done. And then after that, we'll click done and done again. So now what I've done, I've created a partition. I've created a bearing plate with a partition that has a little area over here of 1 inch. So this is ½ inch and the other is ½ inch, creating a total area of 1 inch by 33 inch in this on the solid element. And so that's it. So this is my bearing plate. Now in this modeling video, I've already put everything together. And so I'm going to go to the assembly to show you how everything looks like when everything is assembled. So when we go to the assembly, so this is our bearing plate that we just created. I've already created something similar to that already. So now, how do we tie a bearing plate that is a solid element to the flange, which is a shell element? We're just going to use our tie constraint. And to do that, we go to our module, we go to the interaction. And I've already done the interaction. So how you go about doing the interaction, it's the same process as you've learned in previous video on how to tie stiffeners to flanges or stiffeners to web plate. It's the same process. And so you're going to select your tie constraint, create the constraint, and you're going to select the tie constraints. And once you select your tie constraint, click continue, and you're going to select surface, and then it's asking you to select the main surface. Now, since we're dealing with a solid element and trying to tie solid with shell elements, our main surface will be the surface of the solid element because it's the surface that has the largest thickness. And so for a surface, if we rotate this, we will have to select this surface bottom of our bearing plate. We'll select the bottom area of our bearing plate and we'll click done. That's our main surface. And for our secondary surface, it's going to be the shell element, which will be the flange. And so we'll select surface, and then we select the surface where we're going to put our bearing plate. Our bearing plate is going to lie right on top of the flange because that's where we're going to apply the load. So once you select the surfaces, you will click done. And then it's going to ask you for brown or purple. In this case, this is purple. You select purple. And then it gives you this menu here. You don't have to change anything in this menu because the area on the flange that you have selected matches the area of the bearing plates. If your flange are not partitioned to consider the width of the bearing plate, then you will need to add those partition so that you only select the area that needs to be tied to the bearing plate on the flange. And you click OK, and then you're done. So in this case, I've already done it, so I'm just going to X out of this. And so we'll go back to our assembly, and then now we're going to move our bearing plate from this space back to the top of where it's exactly supposed to be. So in the end, when I zoom out, I have a bearing plate here that has a tie with the top flange. And underneath here, I also have support bearing plates on this side and on the other side at the end here. And it's the same concept. And when we go to our loads, we can see that in this case, I have my pin on this side, my roller on the other side. I have some out of plane bracing on the top flange at the end. And then my load here, because I'm doing some static general step, there's no load here, but I'm going to go to a model where you can see where I have a load. Perfect. So over here, when we go to load, I have created a load here. And then you can see that I have a downward pressure load on my bearing plates. And I've only selected the strip 1-inch area to apply my load. And the magnitude of that load is just is a unit force, right? So it's 1 kilonewton over that area, 1 kilonewton of meter squared pressure over that area. So you will take what that area is, which is 1 inch multiplied by 33, which is that width, that's the area. And so 1 divided by 33, and that will be the ABAQUS apply load that you will apply on your model for your 3-point bending model. So that is all how you quickly go about doing the bearing plate modeling. It's just creating a solid element, partitioning it correctly, and then tying solid to shell element. Remember, when you're tying a solid to a shell element, your solid element is the main surface and your shell element is the secondary surface. And make sure you partition also the flange or your shell element so that you are only selecting the area that needs to be tied to the solid element without having the need to do any tolerances transformation. So that's it. And I hope that this video is helpful.